Hi and welcome back to the lab. And today here on the bench we have a Kenwood TS-711 and the unit won't transmit. So let's see what we can do. Okay, and here is our 711E and well, let's do our first check. So I've already checked here my radio communication monitor, and so we already can say, besides the fact that the potentiometer here is dirty, but the receive is pretty nice without any problem. Okay, but receive was not the problem, but transmit. So since I do not have a microphone for this radio, we simply shorten here the right pins, and you see that it is going into transmit, but there is no RF shown here on my screen, on the meter here, not on the screen. And looking over to my service monitor, there is not real power present, even that here our RF power is fully clockwise, which means full power. There is nothing. Okay, so I've set it here to transmit test, as you can see up here, and I do the same exercise. I simply bridge here the right pins for PTT, and besides the fact that I'm not able to keep here my hands steady, okay, but what we can say, it is sending on the right frequency, more or less, and what we see is 7 milliwatt output. So that means that many stages here in our radio are working, but obviously not the power amplifier. Okay, and that all means we really have to crack open the radio and need to have a look to the power amplifier, or final stage, however you want to call it, and let's see what's going on. Okay, and the radio is set into transmit, as you can see, and just to get a clearer picture of what's going on here, we have here our spectrum of the output signal, and you see here right beneath our carrier we have a kind of AM modulation, and that can happen if the signal is going a little bit through the final stage, which is not amplifying, and then we get some of this odd behavior, but more or less the carrier is there and it is more or less on the right frequency, so 145.525 megahertz, but of course we are too high, so the carrier should be here in the middle, but that is a second issue, because the carrier is out of frequency, which means that most likely the reference oscillator is not aligned after long years of operations. What we can see as well here, 5 dBm, and when I started transmitting it was approximately 6 dBm, which is 6 or 7 dBm, which is equal to 5 milliwatt. What we have seen at first when we checked it on our radio communication service monitor. So that all is nice. Again, yeah. So it was already moving a little bit. So the reference oscillator is getting more warm, and so it is drifting in the right direction. Anyways, so we know that a lot of internal circuits are fine. Otherwise we would not get this carrier. So therefore, let's have a deeper look into our radio. Okay, so the next test we can do is we pick here our signal coming out of our RF board, and we'll supply then our hybrid power amplifier, right? So that is connected, and according to our service manual we should see here minimum 230 milliwatt or more than 3 volt into 50 ohm, of course. So let's see what that means. For the test I bridge here our 2 contacts for PTT once again, and we read our power at our URV5. So that is of interest now. Now let me connect here our bridge, and we see, so that is set to watt, and we see it is 0.268 watt, which means approximately 270 watt, and our service manual is telling us we should see minimum 230 milliwatt. So we are fully in spec with our driver stage. Okay, since we know that our driver stage is fine, we need to focus here on the hybrid final stage, which is a Mitsubishi module, well known, an M57727, so that is the 145 megahertz final hybrid final stage. And well, what I can say already is that all the voltages which need to be present here at our final stage, so that is fine, but when we feed here an external signal into our power amplifier, so we do not get an output, and that is exactly what I was expecting. So yeah, we do not really have a working hybrid module here, so most likely we need to replace it, which is well known that after a time these modules are going faulty for many reasons. So let's try that we really can see both. So I've set here the generator to 18 dBm input level into our hybrid, and here we would normally see the output power in this configuration here. So let me first, that is the set off by the way, so let me set first the radio into transmit, which I'm doing right now. So now radio is in transmit, and when I now switch in here our signal, which we do exactly now, and then we see here our 6 milliwatt output. So that is what we have seen before when we let the hybrid get driven by our RF stage, and you see we really do not get any output. So let me switch it off again because my fan is not running, and the module gets definitely too hot. So that is more or less the proof that we have a problem with our power module. Well, okay, so what can we do? So normally we would directly swap out here our module. Well, the modules are not really cheap, and sometimes they are not any longer available on the market, whereby I believe this one still is. I have to double check, but anyways, they are definitely not cheap. So these modules are known for making interruptions here on our hybrid. So maybe the first step is to really you know, crack off here our little compartment or cover or whatever, to see if we find an interruption on the module itself, and if not, there is no other way to finally replace it. So let's see how to proceed. Okay, so what you can see here is our power amplifier, and of course it is cracked open. So sometimes we have here somewhere cracks in line which we can repair. But in this case here, I've double checked all the connections, and there is definitely no problem at all. So all connections and all the wiring here is definitely fine. But what I found is, well, we have two stages here. So that is the first stage, and that here is the second stage. And what we can check is for short. So for instance, when we go and check here our input, so that is the gate to ground, and you see that is fine. And as well, I can check here our output to ground, and that is also fine without no problems. Okay, but what we can see here, so that is the second stage, or yeah, if you like, the final stage. We can do exactly the same check. So from this side here, we get our supply, our voltage in, so that is a power line, and from the power line down here to ground, everything is fine, and that is the reason why we do not really see a short when we engage the module. So which I mean with no short, that there is no real huge power drawing. But what we can see if we go to the input, so to the gate to ground, so you may hear the beeper, which is indicating that I really have a short either side around. So that is a problem. We can definitely identify here our output stage or final stage as the faulty stage. So that means there is definitely no way other than replacing it, and that is, as I've already said, the problem here, since the original product is obsolete, and if you buy it in China, for instance, you really have a lot of fake modules or parts on the market. So that is really now a challenge. Okay, and once again, so that is our module here. As you can see, M57727 from Mitsubishi, and that is the whole module here. And what we found faulty is here our final stage. So yeah, that is now the point where we really need to see what we can do. Yeah, let's see. Alright, so we have performed Esr test here on our capacitors, and all capacitors are fine, so there is no problem, so we can go ahead. Well, I've put the PCB back here to our fixture to have the right alignment. I mean, you have seen that we need to do it this way. All right, so we have to turn it around this little soldering posts over there, and if we have the new one in and aligned in the right way, then afterwards we have to take the PCB once again out because we need to check here the solder joints underneath. So that is really very often a problem, that when you solder here on the top side, that the solder joint underneath gets loose, and that means that you do not have any longer a solid connection. So therefore it is really important to check the solder joints after you have put in you know, the new module. Okay, so let's take out our new device. Okay, so let's see what we have. A lot of marks here on you know, the housing, and well, not sure if you can see it, but to me it looks like that we have really refurbished unit here. So the glue here, which is around, looks like that it has taken off before, and all the little dents and marks here on the surface makes me really wondering if this is a new module, or if it is only a refurbished one. You see here we have exactly the same. It looks like that a broken component inside has been swapped out. Yeah, look here, all the dents here. So that is very much an indication, and the same here. So normally everything would be closed with glue, which is not what we find here. Anyways, I mean, it does not necessarily mean that it will not work, but it is important to us to know what we have and what we got. And yeah, that looks like flux, which we have here, and here a huge dent again. Okay, so we know, or we can assume or guess, or whatever you want to call it, what we have, but honestly it really does not look new. Okay, anyways, let's try it out. And as you can see, I've put in here the screws to have good alignment here, to really have no stress here on our wires later on. So that is the way you should do it. Put it in, align it with the screws, align the board itself, and then you can solder. Right, as you may see, we have turned here the wire from our module around here our posts. So let's see if you can see it a little bit better when we are going closer. So it is not soldered yet, so that is still all the preparation, but now we are fine to solder it finally in. Alright, so job is done, so it is soldered, and now we go back as we said, so we take it apart once again to make sure that all the posts, the solder posts underneath are fine. So that is to make sure that we do not have interruptions or anything like that. And now I can lift it up like so, and let's see what we have. So solder posts are still fine, I believe, but I will double check it under the microscope. Okay, everything is fine. I have double checked it, so now let me bring it back together. Let's put some new heat grease here onto the power module, and let me bring it back into the radio so that we can do our first test. Okay, so we are ready for testing. So we have here our new PA module in, and everything is ready for testing. Okay, so important now is first, as you can hear, that the receiver is working, and that is something you can hear very clearly. But of course we want to test our power amplifier. Okay, so you see our meters, and up here we have our power meter, and let me now press here our, you can see it, PTT, so that is what we do, and wow, half of a watt. So we see really half of a watt, and yeah, I am not able to turn it up, so I'm just turning here on the power pot, but I'm not able to turn it up or higher. So what we can say so far is simply that, of course, we have output power, so definitely more power than we had with our old module, which we have here, right? So with the old module we did not see nothing. Okay, so now again the question is, did we receive a fake module, which is possible, as we all know. So we have experienced it much too often anyways. The other thing what could do is that here our input from our radio into our power amplifier is too low, and that then of course would end up in a too low final output. To check this, we go into the level diagram. So Kenwood is always so friendly and delivers a level diagram. So this is of course our TX section, and you see that that here is the RF unit, and this here is our final unit. Okay, and what we get here, so here we have a little arrow pointing here at the output of our RF unit, and what we can read is here that it should deliver at minimum 0.23 watt. So that means that is 230 milliwatt. And that is of course something we're going to check to make sure that our output is fine. Okay, and what you see here is that I'm now picking here our signal once again, so we have done it before. This here is the input into our power amplifier, and now we have connected here our power meter. Okay, and it is set to watt, which will indicate the output from our RF unit. Okay, here's again our mic, and let me press PTT, and what can we see? 0.267, so that is 267 milliwatt, or 0.267 watt. And our manual is telling us we expect at minimum 0.23. So we are exceeding the requested 0.23, which is telling us that, of course, here our output stage, our RF unit, is working fine. So the output from our RF unit, of course. That means, and I'm sorry that I have to say that, that is telling us that our module we have received here from Shiner is once again a fake unit. So yeah, we really have seen that very often. The problem is these modules or these components are obsolete, so it is not easy to get them, and that means we have a little bit to rely on what we get from Shiner, and it is really a shame that we have some black sheeps working in that area in China who deliver fake units or fake modules. And you have seen we had a lot of dents here on the housing of our new power amplifier, and it all was already looking a little bit yeah, odd, you know, and therefore I was already assuming that is that really a working unit, and it is not. Okay, anyways, to make the video not too long, I stop here because of course we need to get in contact with the seller, and let's see what he's telling us, but honestly, you know, that is no joke. Okay, thanks for watching, catch you next time.